Okay, so in the last class, we talk about what is the chemistry. Most of the case, we talk about the physical and chemical property. Physical property, that's just talk about the property belong to this substance itself. Chemical property have to talk about the relationship between one substance to another. Okay, and in intensive, extensive property, and we talk about extensive property will changing the value will changing when you're changing the amount of the substance. Okay, like a mass, volume, or dimensions. Okay, so those are all extensive property, but intensive property will not change when you change those amount of the substance, like a density, boiling point, color, or old. Most of those are intensive properties. Okay, and we talk about the intensive property can be used to determine what kind of material it is, or we call the characterize the property of the materials. Okay, in another word, if you see the sum of the color, and all you also see you see the gold color, and you see very heavy, and most of the cases you think about that's gold, right? Yeah, it's because those properties do not change when you change the amount. Okay, so you will based on those properties to determine what kind of material it is, what kind of elements it is. Are you clear? Okay, yeah. And we also talk about classification of matters. And most of the case, we talk about the difference between elements and compounds, right? Elements and compounds are all pure substance, which means in the chamber, we only have this one kind of the substance. But elements is made by only one kind of atom. Even they have a molecule, and those molecules made by same kind of atom, we still call as an element. Okay, the diatomic elements, something like that. Okay, like oxygen gases, hydrogen gases, nitrogen gases, those are all diatomic. Okay, and then the mixture is everything. We have more than one kind of substance, right? This is what we talk about. Elements and compound, again, compound is made by a chemical bond. So those compound cannot be separated by physical means, which you cannot use the physical method to separate a chemical compound. Okay, you cannot. You can only using chemical reactions to separate the chemical bond. Okay, so that's a different. Heterogeneous mixture and the homogeneous mixture, that's only just it basically is, if you have one thing over there, can you tell the different substance in between those mixtures? Okay, if you can, then that means that's a heterogeneous. If you cannot, then that's a homogeneous. Are you clear? Okay, yeah. We also talk about the chemical change, physical change. Chemical change is talk about as something new is generated. There's gonna be something new. They definitely has some chemical bonds are generated or chemical bonds released. Okay, that's belong to chemical change. Okay, the physical change is just a phase change. We talk about gas to the liquid to the solids, or the temperature change. So that is the physical change. And we also talk about the units. Basically, we talk about it as a prefix for the metric systems. The prefix is very important and easy as long as you can remember those, what is the mean of those prefix. Like a nano is just a 1 × 10 to the 1 × 10 to the -9th, the value, which is 1 and have a 9 zeros in front. Okay, so this is a pretty small number, and you just need to 1 nanometer. It just replace the nano to this value. That's it. Okay, so this is how we figure out the value for the nano, mini, kilo. I talk about nano, mini, kilo. Those three are most important. Okay, very common being used. The unit conversion, we just do the practice, so I'm not going to review anymore. And then we're going to talk about the new content for today's parts. Okay, today we already talked about the basic thing for chemistry and the numbers. And then we're going to talk about the atoms, right? When we talk about the classification of the substance, we're talk about elements and the compound. So we start elements first, and then we talk about compound. Okay, yeah. So let's talk about the atoms, the structure of the atom. Structure of the atoms. So in general, the atom, we have the nucleus in the middle, and then we're having the electron cloud in the outside. So those are the electron cloud. Well, so the electron cloud may not be just in a one platform. You need to looking at this in a 3D-dimensional, okay, not just a 2-dimensional for the atom. The atom is a 3-dimensional thing, okay, yeah. So the outside is an electron, it's called the electron cloud. And inside the small dots is called the nucleus. Nucleus. Okay, so the nucleus also including 2 parts. One is called a proton, the other called the neutron. Okay, so electrons is simplified as a small case letter E and negative charge, because electron has a 1 negative charge. This guy has a 1 negative charge. Okay. Proton, we're using the small p to represent, and they have a positive number. So this guy has a 1 positive charge. Neutron is just a small n. You see, those are just the initial of each of those things: electron, proton, and neutrons. Neutron, they do not have a charge. It's a neutral. So that's why it's called neutron. It's a neutral. Okay, no charge. This guy has no charge. Okay. So sometimes when people write the symbol, either you write n or write n0. Okay. So to separate the small n with other small n's, then usually you have a small little zeros on the superscript. So shows this is a neutron. Okay, yeah. So generally, this is a basic particles in the atoms, and you can see atom is the smallest dividable particles. Okay, in other words, once the structure go to the atom, then you cannot cut the atom into even smaller parts. Although inside of the atom we have a small subparticles, but those subparticles cannot be sustained alone. Okay, so we can only the atoms is the smallest particles that we can, for any of the substance. Okay, so those are the structure of the atoms. And if you're talking about the mass. If you talk about the mass of atoms, and generally, we only count the mass of proton plus mass of neutron. Right.
So that's just the nucleus.
Yes. So generally, it's just the mass of the nucleus. Okay. Yeah. Well, it doesn't mean the electrons do not have a mass. Okay, electron, this particle is still a matter. Okay, but the mass of electrons is very, very, very small. Okay, much smaller. is much, much smaller than proton and neutrons. So generally we can ignore it. Well, usually it's about like a 1 over smaller than 1 over 1,000. Okay, so it generally is a 1,000 times, even more than 1,000 times smaller than the nucleus, than the mass of proton and mass of electrons, neutrons. So generally we're ignore it. Okay, just like if you have a really big number, right? 1 plus 0.001 in general is equal to 1, right? This is based on what we talk about for accuracy. Okay, do you understand what I'm talking about? Okay, so that's why we ignore the mass of the electrons, but doesn't mean electrons do not have a mass. It's just very, very small. But if you're talking about the size of the atom, and then we generally ignore the size of the nucleus. The size of the nucleus is very, very small, but we count, that's gonna be, we count the size of electron cloud. Okay, yeah, so in another word, just like here, the electron cloud has a much, much bigger size compared to the size of the nucleus. So we generally ignore the size of nuclear. And when you're talking about size of atom, then that's just the size of the electron cloud. Okay, yeah. So if you're talking about the atoms, atom is kind of like a ball, and then the ball shape of the ball is actually, it's just electrons, I mean, orbit around it. Okay, so that is the size of the electrons. In another word, if the electrons are moving, and then the electron cloud is moving, then the size of the atom will also move, also change. Do you understand what I'm talking about? Okay, yeah. Okay, and then we're going to introduce some other numbers. I think I believe you already learned this before. Okay, for example, we have a number shows over here 19, and there's a capital K, and here it shows a 39.0983 shows up here. So there's several numbers shows in the periodic table, and each of the elements are doing the same thing. The first number shows over here, and we call it is atomic number. This is called the atomic number. So in general, atomic number is just equal to the number of proton. Okay, so atomic number is the same number as atomic number. So the number of proton. In another word, in the periodic table, we order the elements by the number of the atomic number, a number of the protons. Okay, by the number of protons in this case. And the capital K shows that here, that's going to be the symbol. This is a symbol of potassium. Okay, this is a symbol of potassium, and each of the elements has their own symbol. And this number is called the average atomic mass. We will talk about this next class. And again, so I will send a video, okay, from YouTube, and just several minutes here, the videos. I hope you can watch that before the next class, okay? And this is give you some introduction about what exactly is the average atomic mass. And next time we will do the calculation with it. Yes. Is that based on the isotope? Yes, it's based on the isotopes. Yes. And we will talk about what is the isotope just a few minutes later. Okay, so this is a basic thing in the periodic table. And there's one more number, it's not shows up there. That's called a mass number. Mass number, okay? And again, we just talk about the mass of the atom it generally is a mass of proton plus mass of neutron. So the mass number and generally it's just the number of proton plus number of neutron. Okay, yeah. So then what is the difference between mass number and the mass of the atom or atomic mass? So what is the difference between mass number and atomic mass? Okay. Sorry, not atomic mass. Okay. Atomic mass is we talk about is exactly the mass of the atom. Okay, that's called atomic mass. Okay. Not this one. This is the average atomic mass. But the atomic mass is talk about if we have an atom shows off here. Okay, what is the mass of this atom? Then this is the atomic mass. Generally, it's just a mass of this atom. Mass number is talk about is the number, but this number is very close to the mass. Yeah, it's very close to the mass of these atoms. Okay, so why we can do so? Let's just come back to look at this equation. The mass number is equal to number of proton plus number of neutrons. Okay, and the people generate one of the number, a unit is called atomic AMU. It's called AMU. The AMU refer to atomic mass unit, and atomic mass unit is a very, very small. Okay, so I can just search that for you. Okay. So AMU to gram. Okay, so you see AMU 2 gram. That's very, very small, 1.67 times 10 to the negative 24. Okay, so that's gonna be a really, really small 1.67. 1 AMU is equal to 1.67 times 10 to the negative 24 gram. Okay, so that's why nobody gonna using this unit unless you're talking about atoms. Okay, so that's why we give it a number unit. It's called the atomic mass unit. Okay, so in general, the people figure out the mass of the proton and very, very close to 1 AMU. Okay, it's not exactly 1 AMU, but very, very close. Okay, and also people figure out the mass of neutron is also very, very close to 1 AMU. So generally, that means if I have 1 proton, then that's 1 AMU. 2 protons and 2 AMU. 10 protons, 10 AMU. So if we have a number, I have a 10 numbers, 19 numbers of the atom protons, then that's called 19 AMU. That makes sense, right? Yeah. And the neutron is the same thing. So that's why you see the number of proton plus number of neutron together generally is equal to a certain number, but this number is just very close to certain numbers of the AMU. So that's why this number, the mass number, is very, very close to the exactly atomic mass. Elizabeth, do you have any question? You good? Okay. Okay, so this is that is why this is difference between mass number and atomic mass. Atomic mass, they do have the unit. Mass number do not have a unit. It just give you our numbers. Okay, yeah. So then if we know everything of here, then we're going to write we can using any of the, if we know some of the combination between proton, neutron, and electrons, and we can write a symbol for anything. Okay, for example, we have the proton. if the proton, neutron, and electrons. So the proton, if we have 6 protons, and we have 6 neutrons, and we have 6 electrons, then what we can write? So first, we're going to write a symbol. And on the bottom left parts, we're going to write, this is where you put atomic number. You put the atomic number. And the top left part is where you put the mass number. And the top right part is where you put the charge. Where you put the charge. Okay, yeah. So I think I forgot to mention, how to calculate the charge. Okay, but first, this is how we write the symbols over here. Okay, yeah, and then let's find a place. I'm going to write how to write the charge, how to figure the charge. So in general, if a neutral atoms, or when we talk about the atom, they must be neutral. When we talk about the neutral atom, and the number of proton in general is the same, just a number of electrons. That makes sense, right? Because if we have, for example, we have 5 protons, and then we have 5 electrons, and the positive charge and negative charge are canceled to each other. The overall atoms will be neutral, right? So if you have a 5 proton and 5 electron, in general, you got a 0 charge for the atom, right? Yeah. So this is why generally the atoms is neutral, because they have the same number of electron and proton. But if we don't have a same number of proton and electrons, then we're going to call those are different ions. Those are called ions. Ion has no, different number of proton, and the number of proton is different than the number of the electrons. Okay, so that's what we call the ion. But if you have the protons, if it's larger than the number of the electrons, okay, which means you're gonna have something like this. Okay, you have 5 proton and you have 4 electrons, and then the 4 negative charge is being canceled by the 4 positive charge, and there's 1 possible charge left over, so you're gonna have a 1 positive charge. Okay, so then where this particle has a positive charge, then we're going to have a positive charged particles. And this is what we call the cation. Cation. So if the proton number is smaller than the number of electrons, then we're going to have a negatively charged particles. Then this is called the anion. Okay, anion. But both of those are easy to figure out calculate the charge. For example, you're always using the number of charge or just a charge. Charge, then that's just equal to the number of protons subtract the number of electrons. Even you got a negative. The negative means this has a negative charge. Okay, yeah, for example, for this guy, if we have 5 positive charge and 4 negative charge, 5 minus 4, then you got 1 positive charge for this, 5 minus 4. But if you have, in this case, you have 4 negative charge and 4 positive charge, 5 negative charge, you're still going to using 4 minus 5, because the electron number is 5. 4 minus 5, you got a 1, negative 1, negative 1. So negative 1, that's also a charge, but this is a negative charge. Okay, yeah. So generally, this is how we figure out the charge. Okay, and then we can go back to looking at the symbols like this. Okay, so we now in this setup we have a 6 proton, 6 neutron, and 6 electrons. So now first we're going to look at what kind of elements it is. Elements is carbon. Okay, number 6. Number 6 is carbon, which is the proton number. Proton number 6. So you're gonna write the carbon shows up here, and then of course you're gonna put the 6 over there. This is called a 6 carbon. And then you're going to write the top right, top left is a mass number, which is proton plus neutron. 6 plus 6, so you're gonna have a 12 shows up there. And is there any charge? Well, it looks like there's no charge shows over here. And then you don't have to write anything. You don't have to write a 0, okay? Usually, when we write the neutral things, we're not going to write a 0. Just leave it alone, okay? Leave it blank, that's it. So this is what we call this is called a carbon 12. This is called a carbon 12, okay? Yeah. And if you have another setup, the proton has a 6, neutron has 7, and the electron has 6. And then you will see this guy will be still a carbon because the same number of proton. And you're having the 6 shows over here, 13 for the mass number, and no charge. And this is called a carbon 13.
How we determine isotopes? Like that's what we're
Yes,
looking for?
yeah. So I'm going to keep continuing, okay? So just to give you the examples. And we have 8 neutrons, and the electrons still the same, okay? Then this guy, it will be carbon 14. This is called a carbon 14, okay? Yeah. So again, this guy has the same number of proton, but they are having the different numbers of the neutrons shows up here. And I need to emphasize is here, these guys are belong to the same elements. They are all elements. So carbon 12, carbon 13, this is carbon 14. Carbon 13 and carbon 14, those are all carbon elements, but they are called isotopes. Okay, those are a group, is a group of the, so the definition of the isotope is a group of atoms that belongs to the same elements very, very important. It belongs to the same elements. If it's different elements, we cannot call them isotope. These guys have to belong to the same elements. Okay, they belong to the same elements, but they're having the belong to the same elements, which means they have a same number of proton. But they have a different number of neutrons. Okay, they have a same number of proton, but they have a different number of neutrons. So this is what we call the isotopes. Okay, so that's why I say they have a same number of 6, 6. Those are all 6. So proton number are all 6. So they belong to the same isotope, but they are having the different number of neutron. So that's why they have a different mass numbers. Okay, the mass number is different. If we have a different mass number for the same elements, then definitely for sure those are isotopes. Okay, those are isotopes. Okay,
And
So-
like that little X thing where there's, if you go up a little bit, like that little X thing that you made,
mhm.
the blank spot, that doesn't mean anything.
Well, this X is a symbol, is where I put a symbol there. I'm going to give you the examples. It's just any of the symbol, the bottom left, that's gonna be at the atomic number.
Okay,
The top left is a mass number, and on the right side, that's a charge.
okay, got it.
So let's see, for example, okay,
So that would be whatever symbols, whatever.
whatever the symbols, okay, sometimes we can have some of the conceptual questions like this, okay. Now we have those 6 elements over there, 6 atoms, okay, 6 atoms, and then let's see. Okay, so you see, we got a 1, 2, 3, 4, 5, and 6. So those are 6. Again, make sure those symbols shows over here is called atoms. Okay, this is specific. Give you a certain atoms. So we have 6 atoms that shows over there. Could you help me group which and which are isotopes? Which one and which are isotopes? Okay, yeah, those are conceptual questions. You don't have to determine based on the symbol, but you can based on the mass number and atomic number to determine. Yes, Casey.
Yeah, I can.
Sure, go ahead.
Okay, so, now are 20, 9 and 9.
No, we have the 6 numbers. Okay, so which one and which?
So,
For example,
One is.
1 and 3. Is it 1 and 3 or 1 and the others?
oh,
1 and 4. 1 and 4, those are isotopes.
okay, yeah.
Because they are having the same number of the atoms. Okay, so that is why you need to remember where is the atomic number shows in the symbol. Okay, not the top parts. The top parts is not, it's a mass number.
The different.
Okay.
atomic.
So only the same atomic number, which is on the bottom left, you need to looking at, that's gonna be the isotope. Okay, and 2 and 3 are isotopes because they are having the 10 atoms atomic number, and the 5 and 6, those are isotopes because they are having the same atomic number. Okay, so this is a conceptual question. Okay, give you a symbol shows where you need to looking at to find the paired isotopes. Make sense? Okay. Do not looking at the top parts. Top parts is a mass number. It just give you the mass of certain things. Okay. Yeah. Very, very important. Okay. What else I need to say? Let me think about. Okay, when should we start our lab? What time?
This ends at 5:25 and the March starts at 5:30.
Okay, usually we start at 5:30. Okay, okay. So now let's just work on. Okay, so I think you should have everything. Let's do some practice. Please turn the study guide to the page 17. Study guide to page 17, and let's just twist our mind a little bit. Okay, yeah. That's a practice. And once again, the study guide also has a lot of the unit composition and the density part. If you still have a hard time on that part, please practice. Okay, page 17. Okay, page 17, and those are the to doing the calculation for the symbols for proton number, electrons, and atomic number, mass number, something like that. Okay, let me just give you one of the examples. Okay, I already put the table shows over here. Okay, so let's just do the first. Let me just do first questions. The first question, this one, they give you the symbol and try to let you write everything over here, okay? And here you need a periodic table. So first, Na. Na, that's a sodium. Shows over here, sodium. And if you're looking at the top parts, that's 11. And the 11, that's the atomic number. So you will see the atomic number is 11. And again, the atomic number and the number of proton is the same. So if the atomic number is 11, proton number is also 11. And on the superscript on the top left parts of the symbol is a mass number, which means the 23 shows over here. And since the neutron is made, neutron plus proton is equal to mass number. So 11 plus something equal to 23, the something that's going to be 12. Okay, so neutron number is 12. And what is the number of electrons? If you're looking at the symbol shows here, there's no anything shows on the superscript, which means this guy is a neutral. Okay, if this atom is neutral, then that means the proton should be the same, just like electrons. So you have 11 proton, and you should have 11 number of electrons. Are you clear?
Mhm.
So you can go ahead to work on the rest of the others. Okay, yeah. And later, don't forget to write down the mass number for each of the atoms. And this is also the practice for you to be familiar with the paragraph.
We're gonna go over this. Oh,
Okay, so if you have finished to the iodine, iodine 131, then you can stop. And we can review the first parts. I believe the rest of parts already shows in on the canvas. I think the canvas module 1 or module 2. Okay, it shows the key for these parts. Okay, yeah. So let's just review this. Before we doing this, I need to emphasize one things. You probably see some people write. For example, we write 9 potassium 19, or just potassium, or write potassium 40, or potassium 39. Okay. So what is the difference between the first one and those? You know what is the difference?
Let's see, like, first one have what's on the periodic table as like weight or the points between mass.
Okay, so let's look at this. Okay. Yeah, so for both of those, do we know number of proton?
19.
It's a 19. So we know this is 19. This is also 19. This is also 19, right? Do we know how many electrons in over there? Yes, because everyone is neutral, right? So we know this is 19. This is also 19. This is 19. Do we know the number of neutron?
Well, it may vary.
No, first one we don't know. Is there any sign shows over here shows telling you what's the number of neutron? No, you cannot assume neutron is 19. Okay, it didn't show any of the things. So this guy don't know the neutron, but this guy do. 19 plus something equal to 40. So this one is 21, and this one is 20, right? So those two, they do know the neutron of neutrons, but first one don't. So what does that mean? That means if you write the mass number shows up there, this already specific talk about a certain atom, because we know atom made by neutron, electrons, and protons, right? If you're telling you this mass number, so that means this guy already gave you talk about a specific atom. Okay, so this is also a specific atom. Okay, and both are those we call those two are isotope. And again, isotope is also a group of atom, right? It's a group of atom, but this one is not an atom. It's not a specific atom. It's what we call the elements, because this is a group. Because I don't know what is the neutron here. The neutron could be 21, could be 20, or could be 19. The different neutrons. This K is general, is talking about a group of atoms that has a proton number is 19, which is an element, which called potassium. But it didn't specifically talk about what kind of atom it is, what kind of isotope it is. You understand what I'm talking about? Okay, so very, very important. Yeah, so that's why here, since you all know the mass number, so that's why you need to specific to write down what is the mass number shows up there. Okay, if you don't write, then people assume this is you're talking about general elements. Are you clear? And so that is why for in these cases, you can call this is a potassium 40. This is a potassium 39, but you can only call this potassium. Okay, but you don't know what is the specific atoms it is. Okay. All right, so this one, mass number 40, so that's why you write 40 up here. The potassium is 19 and 19 protons, and this is 21 atoms, neutrons. And then this one, we have 52, 38 proton, and 38 for the atomic number. Mass number is 38 plus 50, that's a 90. So this guy 38 strontium. It's a strontium 90. Strontium 90. Next one is fluorine. Fluorine has a 9 proton, which means a 9 atomic number. And since the proton number, neutron is 10, so mass number is 19. And since this guy is no charge, so that's why it's 9 for the electrons. So this guy is 19, fluorine 19.
Aren't typically, no, maybe I'm just getting confused here, but those ones past the line, are they negative? Charge? Typically?
Yes, I haven't talked about that yet.
Oh.
Yeah.
Okay.
Yes,
Fine.
for the one over this side typically is negative, but doesn't mean it cannot be positive. Okay, yeah, but it's just really, really hard, or sometimes it's artificial made. Anyway, for a 20, so this is also 20, and this is a 40, so this is 21. Okay, and you say 20, then this is a calcium, and this is a calcium 41, and this guy do have a charge, and we have a 20 proton and 18 electrons, so have a 2 positive charge here. When you write a 2 positive charge, you either write a 2 plus or +2, both okay, yeah. But typically, I prefer is a number first, charge later. But if you write a +2, then also fine. Okay. Next part of 50, and this is a 50. So this is 72, so 122. And this is 50 is a 10. This is a 10 and 122. And that's it. Iodine. You see, iodine is 53. So 53. This is 53. And mass number 131. So 131 minus 53. That's 78. 78. And this is also 53. So now then you got the iodine 131. Are you clear? Okay. You got it? Okay, so generally this is how we write. Okay, typically to tell the difference between elements and atoms. Okay, if you have a mass number, this is specific talking about the atom. Okay, so let's pack our things and then we will move to the lab. Okay, and if you don't have a chance to write down the template, you still have a little bit of time to write the template.
My first thing. The air fryer. But those would be good. You got to throw everything in the air fryer. But if I go get Sonic on the way home from us, then I won't want to use it anymore. So I'm not there. Yeah.